Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 31, Types of Chemical Reactions, Part 6. Here are our objectives for today's video. Pause here. So a titration is an extremely important experimental technique, and it is used to determine the concentration of a substance in a solution. So how this works, and we are going to do this in the lab, you have a substance of unknown concentration placed into an Erlenmeyer flask. So for example, we're going to be titrating vinegar. We're going to find out what the concentration of acetic acid is. We're going to take our vinegar, we're going to place it into an Erlenmeyer flask. Then we're going to take a concentration of known concentration, and we're going to add it to a Biuret, and then we add from the Biuret to the Erlenmeyer flask, drop by drop, until the reaction is complete. The way that you know a reaction is complete is typically by placing a pH indicator in with the Erlenmeyer flask. Once you have a color change, you know that the reaction is complete. You're able to measure the volume of whatever it is that you are adding and use this to do stoichiometry calculations. Pause here. Before actually getting into how to do a calculation, which the calculation is more or less the same calculation as what we did before, you can always assume that you're going to have 100% yield for these. The reason why is because when we're dealing with strong acids and strong bases, in general, you just have 100% yield. And then any water that is generated, you can assume that that volume is negligible and not affecting your calculation. Pause here. So this is a stoichiometry calculation, which means that you need a balanced chemical equation before you can do anything. So I am looking for HCl concentration, which means that I want moles of HCl over liters of HCl. So I don't know my moles, but I do know that I've got 35.4 milliliters of that, and then I can just convert that to liters. So I'm going to need to figure out moles of HCl. So the way that I do that is by taking what I have of NaOH. And then I go to my balanced chemical equation. Plug and solve. I'm rounding to 3 sig figs because 0.100 has 3 sig figs. So then I take what I was working with before, around my final answer to 3 significant figures. And I'm left with 0.599 molar. One thing I want to point out, in this equation, it would have worked if you used M1V1 equals M2V2. Do not do that, do not do that, do not do that. The only reason why that works is because I have this 1-to-1 mole ratio. Once you start having things that don't have a 1-to-1 mole ratio, so for example, this H2SO4 with the NaOH from a prior video, all of a sudden it doesn't work. So you're always going to have to find moles over liters, divide. You're always going to have to do it in these steps, and it's going to be a lengthy problem, and you're also always going to need to write out the balanced chemical equation. If you skip any of those steps, sometimes you will get lucky and you will get the right answer, but sometimes you will not get lucky. So you're always going to want to do these steps. Thank you so much for watching, and have a great night.